Hello everyone, welcome back to practicals on embedded system course. So we are in practical number 6. The title of this practical is development and execution of program in C to send data serially on serial port of 8051 continuously. Okay, so in other words, we are going to study serial port programming in C in this practical number 6. Okay, so in particular, we are going to study serial port programming in mode 1. That means 8-bit UART mode, that is number of bits that can be sent uh, asynchronously, that is 8 bits, number of data bits 8 bits, uh, that is mode 1, for transmission of data byte serially on TXT pin. Okay, that is pin number 1 of port 3. So we are going to study serial transmission in this practical. Okay, because in simulator it is not possible to study serial reception of data that can be received on pin number or pin RXT. Okay, so there are two pins, TXT and RXT, that can be used in serial communication to transmit or receive data serially. Okay, so in this practical, we are going to study serial transmission in mode 1, that is 8-bit UART mode. Okay, so these are the programs we are going to study in this practical. So first, program number 1, write a 8051C program to transmit the message YES, capital YES. This is the message we are going to transmit serially, that is on pin TXD of 8051 at 9600 baud rate, means at the rate of 9600 bits per second. So we are going to use 8-bit data format, that is number of data bits will be 8. Then one stop bit. So it is not necessary to mention because there is no option to select the number of stop bits. So always stop bits will be equal to 1. Okay, but it is a trick. Okay, so it has been asked to use one stop bit, and we have to transmit this message YES continuously after every 500 millisecond. Okay, in between, use timer 0 in mode 1 to generate the delay of 500 millisecond and assume crystal frequency 11.0592 megahertz. So crystal should be 11.0592 megahertz, otherwise we cannot generate such a standard baud rate, that is 9600 bits per second. To generate such standard baud rate, we have to use crystal of 11.0592 megahertz. Okay, that should be connected between X1 and X2 pins of 805. So this is the first program, that is to transmit message S continuously with 500 millisecond delay in between. Second program, write a 8051C program to send two different strings serially on serial port of 8051. Assume a switch is connected to pin number 0 of port 2. Monitor this switch and make a decision as follows. If switch is equal to 0, that means this pin number 0 of port 2 which is connected to a switch that is named as SW, and if it is equal to 0, that means that switch is not on. Okay, because that switch is connected in between pin number 0 of port 2 and ground, other terminal of switch is connected to ground. So if that switch is closed, so that means that pin will be connected to ground. Okay, and then we can say that switch position is equal to 0, means if switch is closed, SW will be equal to 0. Then you have to send your first name, whatever first name, your first name, that you have to send serially. Okay, with a one character at a time. And if that switch position is equal to 1, means that switch is open. Okay, then you have to send your last name, whatever characters are there sequentially, you have to send these characters serially on serial port, that means TXD pin of 805. Okay, so for this again you have to assume crystal frequency is equal to 11.0592 megahertz and baud rate required is 9600, and it is not B, it is 8-bit data format and one stop bit. Okay, so these are the programs we are going to study in this practical. Okay, so let us start with program number one, which I have already written and I have already opened it in a, kill compiler. Okay, I will just open that kill compiler. Okay, so this is a program. I will add that program in my project file. Okay, so program add existing program, so prog1.c, I will add it. Okay, and I will open that program. So okay, so this is the program, so this is the title of the program. Okay, and this is the title of practical number 6, and this is the title of program same. Okay, so now what we are going to do, we are going to send message yes serially on TXD pin of serial port of 8051. Okay, and after transmission of this message completes, we have to wait for 500 millisecond. Okay, so this 500 millisecond, to generate this 500 millisecond, it has been asked that use timer 0 in mode 1. Timer 0 in mode 1 means timer 0 should be configured as timer in 16-bit mode to generate this 500 millisecond delay. So for that, we have to determine the initial count to be loaded into timer 0 registers, that is TL0 and TH0. Okay, so this calculation we have already done in previous program. Okay, so same calculations we are going to perform here, that is to calculate initial count to be loaded into timer 0 registers in mode 1. Okay, that is 16-bit mode. So we are assuming crystal frequency, that is 11.0592 megahertz, and these four steps we have to follow to determine the initial count. Okay, first divide the desired delay by 1.085 microsecond, because that crystal oscillator frequency we are assuming 11.0592 megahertz, which is internally divided by 12. Okay, so so that period of that frequency of 11.0592 divided by 12. Okay, so that is equal to 1.085 microsecond, means count in timer register will get incremented after every 1.085 microsecond. So divide that desired delay by 1.085 microsecond, then whatever value we get in step 1, assume that value is n in decimal, so subtract that value from 65535 and add 1 into it. Okay, so after we get that value in decimal, convert in third step, convert that decimal value into equivalent hex. Okay, and we will get YYXX as the equivalent hex number. Okay, and that is the initial count value to be loaded into timer 0 registers. Okay, to generate desired delay. Okay, that is TL will be initialized with XX and TH will be initialized with YY. Now for, in our case, we require desired time delay of 500 millisecond, so that will get divided by 1.085 microsecond in first step, that is 500 millisecond divided by 1.085 microsecond, so value comes 4,60,829. Okay, so we can simply uh, write here 4,60,829, that is 4,60,829. So that cannot be subtracted here, that value is n, so then cannot be subtracted from 65,535. Okay, so what we can do, we divide this by 10, that is 4,60,829 divided by 10, I will get 46,083. Okay, which could be value n, because that can be subtracted from this 65,535. And what value we get after calculation in step 2, I will get 19,453. Okay, once we subtract this 46,083 from 65,535 and add 1 into it, I will get 19,453. Okay, convert that decimal number 19,453 into equivalent hex, I will get 4BFD. Okay, so this 4BFD is the initial count value to be loaded into TL0 and TH0. So TL0 is loaded with the this FD, lower byte, and TH0 will be loaded with this 4B, that is upper byte. Okay, and this initial count that is loaded into timer 0 register, and once we start timer 0, it will generate delay of 500 millisecond divided by 10, because here in step 1 we have divided whatever initial count, okay, that is divided by 10. Okay, now to generate 500 millisecond delay, okay, we have to repeat the timer 0 delay 10 times. Okay, then only we will get 500 millisecond delay, because it is not possible to achieve 500 millisecond, okay, uh, delay in one run by timer 0. Okay, because it is beyond its capacity. So maximum delay can be generated uh, by timer 0 in mode 1 when we load initial count, that is 0000 into TL0 and TH0. So that is not possible to achieve a 500 millisecond delay. So we have to repeat such a delay, okay, with initial count value of 4B FD loaded into TL0 TH0, okay, 10 times. Then that will generate delay of 500 millisecond. Okay, so this is the program. So include reg51.h, then we are declaring two functions. First is timer 0 delay function, timer 0 underscore delay. So once we call this function, it will give us delay of 500 milliseconds. So that program is written in this function, timer 0 delay function. Next function is void serial underscore tx, and in opening and closing bracket, okay, uh, unsigned char x. Okay, so this function serial tx, it will transmit the character we are passing to this function serial tx. Okay, so we are declaring these two functions. We will study these two functions after we study main program. Okay, so we require this declaration of these two functions because we are accessing these two functions before their definition comes. Okay, that is from main function. See here, so this is the main function. Main program is written in this main function void main void. So in between this opening and closing braces, the main program is written, that is between this opening and closing braces, main program is there. So unsigned char z, z is declared as unsigned char type of variable in which I can load any value in between 0 to 255. Then t mod is equal to 0x21, means t mod means timer mode register. We can configure timer 0 and timer 1 by using this t mod sfr, in which I am loading 0x21. So if I load 0x21 hex number into t mod, what will happen? It will configure timer 0 in mode 1 and timer 2 in mode 2, that is 8-bit auto reload mode. Because this timer 1 we are timer 0 we are using to generate time delay of 500 millisecond, and um, sorry, this is not timer 2, timer 1. Okay, it's timer 0 and timer 1. So timer 1 is configured in mode 2, that is 8-bit auto reload mode, and that is required, okay, to set the baud rate of serial port of 8051. So when we are using serial port for transmission or reception of data, so timer 1 is used to set baud rate. Okay, and for that timer 1 should be configured in mode 2, that is 8-bit auto reload mode. Okay, then th1, as I said, th1 is loaded with 0xfd. So when I load th1, that is higher uh, timer 1 register, okay, if I load that with 0xfd, that will generate baud rate of, or that will set baud rate of serial port of 8051 of 9600 bits per second, and that is been asked in the program. Okay, so then scon is loaded with 0x50. Okay, so that will configure serial port in mode 1, that is 8-bit UART mode. Okay, so 8-bit data format with um, that is universal asynchronous reception transmission mode. Then tr1 is equal to 1, so that will start timer 1. Okay, and that will set baud rate of 9600. Then while 1, okay, so whatever statements enclosed in between opening and closing brace of this while one means infinite while loop. Whatever statements that are there in the while loop, that will be repeated continuously or infinitely. Okay, now see here what is written inside this while loop. Serial underscore tx means this, there is a function having name serial underscore tx. To this function I am passing character y. Okay, so in single quotes y is written, means this is a character y, means ASCII code will, its ASCII code will get passed to this serial underscore tx function. And what this serial underscore tx function will do, it will transmit that character y, okay, serially on txd pin of serial port of 8051. Okay, and after that transmission of character y completes, I am calling timer 0 delay. Okay, so this timer 0 delay generates, this function generates delay of 500 millisecond, and to generate that delay we are using timer 0, so the name is timer 0 underscore delay. So after that, after transmission of y and a delay of 500 millisecond, we are transmitting next character, that is e. Again we are calling delay of 500 millisecond, and again we are transmitting last character, that is s, and again we are calling 500 millisecond, because that is been asked in the program. So once this while loop executes, what will happen? YES message will get transmitted serially. Okay, so here we can modify program, because I think after transmission of this transmission of message, okay, we have to wait for 500 millisecond. Okay, so here I will modify this program like this. So after transmission of YES characters, okay, there will be delay of 500 millisecond. Okay, so slightly I have modified the program as per the statement given. Okay, that is after transmission of this message YES, we are calling delay of 500 millisecond. Okay, now we will go into these two functions, that is serial tx and timer 0 delay. Now see here, this is serial definition of serial tx function. Okay, void serial underscore tx unsigned char x, and inside this, see, inside this, so to this function I am transmitting the character to be transmitted serially, and that character will get assigned to this function local variable x. Okay, and inside this function, that x I am loading into sbuf, that is the character to be transmitted serially, and the character you want to transmit serially, that should be loaded into this serial buffer register, sfr, sbuf. Okay, so once it is loaded into sbuf, that is character to be transmitted, what will happen? um, it will get framed in between start bit and stop bit, and this whole, okay, so these 8 bits of characters to be transmitted, plus one stop bit and one start bit. Okay, so total bits will be 10, and these 10 bits will get transmitted serially on txd pin. So this will happen once we load that character code, ASCII character code in 8 bits into sbuf. Okay, and after transmission completes, what will happen? Ti flag bit, that is transmit interrupt flag bit, will get set. Okay, so after loading this character ASCII code into sbuf, our job is to just monitor whether that transmission is ended or not, and that we can check by checking this ti flag bit. Okay, so initially ti flag bit is 0, and once transmission completes, that flag bit, ti flag bit, will get set. Okay, so we will, this while ti is equal to 0 semi comma, so your program will be in loop until ti flag bit gets sets. Okay, and when ti flag bit gets sets means what? That transmission completed, transmission is completed, transmission of whatever character in x, okay, that we loaded in sbuf, its transmission completed, and this while loop get terminated, and control will come to the statement below. Okay, so statement below, see, ti is equal to 0, again we are resetting this ti flag bit for next cycle. Okay, and again from here program control will come to the next statement below, and here what we are transmitting next character, that is e. Okay, in this way we are calling this serial tx function, okay, 3 times. Okay, with a character to be transmitted serially, yes, and after that we are calling this timer 0 delay. So from here control will go to timer 0 delay. Okay, so uh, here one modification we have to do, we have to repeat this timer 0. Okay, so here we have to repeat it for how many times? So we have to repeat it. Z is equal to 0, Z is less than 10, and Z plus plus, because we want 500 millisecond delay. Okay, so we have to repeat this repeat this timer 0 delay 10 times. Okay, so it will generate 500 millisecond delay. Okay, so this modification we have to do. So here in this timer 0 delay function we are loading ts0 and tl0 with uh, 4bfd. Okay, then we are turning on timer 0 by making tr0 bit equal to 1, and then we are waiting for overflow, okay, of count in tl0 th0 from all ones to all zeros. Okay, once that happens, control will come down to the next statement. We are resetting tr0 bit. Okay, and we are resetting tf0 flag bit. Okay, because that is okay, we are resetting tr0 bit means we are stopping timer 0, and we are resetting this tf0 flag bit because it was set, okay, due to roller of count. Okay, so once this timer 0 delay function execute for once, it will generate delay of 50 millisecond. Okay, so that we are calling how many times? 10 times to generate delay of 500 millisecond, because that is been asked in the program, that is delay of 500 millisecond. Okay, after sending a message once, we have to call, or we have to wait delay of for the delay of 500 millisecond. Okay, so this is the program. Now let us check the output. So for that, first I will build the program, so there are no errors. Now go into I will go into debug session, start and stop. Okay, okay. Now see here. So this is a serial here in under peripherals. Under peripherals, I can check serial port information here. Okay, so here mode is 8-bit shift register. I can monitor various SFR related with serial channel or serial port of 805, like SCON, then SBUF, then bits from SCON. Okay, then uh, baud rate. Okay, transmit baud rate, receive baud rate, and status of this uh, flag bits TI and RI. All these things I can monitor. Now I will step execute this program. So control is here. First I am configuring tmod. Okay, so tmod will get loaded with 21, then th1. Okay, so then scon. Okay, and then tr1. Okay, so once I start timer 1, see here baud rate is set to 9600 bits per second. Okay, transmit baud rate and receive baud rate. Then scon is loaded with 50, sbuf is initially 00. Okay, so mode is 8-bit variable baud rate, means obviously it is UR, that is mode 1. We have configured serial port in mode 1. Now first we are transmitting Y. Okay, so here only thing is that I have to in this. Okay, so here I will insert breakpoint. Okay, so see here, so from here control will go into this. Okay, serial tx. Okay, and x, what is value of x? That is 59, which is the ASCII code of y. Okay, because now we are transmitting character y. Okay, so ASCII code of y will get assigned to this variable, local variable x, and that we are loading into sbuf. Okay, now see here sbuf is loaded with x. See here sbuf is loaded with 59, which is ASCII code of letter y. Okay, and then uh, we are waiting until TI flag bit gets set. Okay, so I will run here from here, and once that TI flag bit gets set, control will come out and go to the next statement on which we have added breakpoint, means execution will stop here. Okay, now see here TI flag bit is set here. Okay, because transmission of this 59, that is ASCII code of Y, letter Y, is now finished. Okay, so TI flag bit is set. Now we are resetting this TI flag bit for next cycle, that is to transmit next character. So that should be reset. So that will get reset, TI flag bit get reset, and we are going back to the main program. So now transmission of Y is ended. Similarly, transmission of E and S happens. Now I will use this step over, okay, to come out of this. Directly we will go, okay, to the next part. Okay, so here breakpoint is there, means here now SBUF is loaded with ASCII code of 45, which is ASCII code of letter E. Okay, and its transmission is ended because this TI flag bit is set, and program execution is stopped because we have added breakpoint here at this statement. So I will go next. Okay, again here I will run here. Okay, now this S is being passed for the transmission, so run. So here ASCII code of this S is 53. Okay, and TI flag bit is set, means transmission of that as that is character S is completed. Okay, and we are coming back to the main program. Now here this is the program that will generate delay of uh, 500 milliseconds. Now directly I will run the program. Okay, so I will remove this breakpoint from here, so that continuously the message S is being transmitted continuously with a delay of 500 millisecond. Okay, so I will just run the program. Okay, so that transmission is so fast that we cannot monitor here TI flag or whatever data in SBUF. Okay, but it is running. It is continuously transmitting message S. Okay, serially on TXT pin of serial port of 8051. Okay, so in this way the program this program executes, which transmits message S continuously with a delay of 500 millisecond in between. Okay, so this is program number 1. You can check this program. Now I will go to the program number 2. Okay, so I will remove this program. Remove. I will close this program window, and I will add program number 2, which I have already written. I will double click on this so that I can display the program. So program number 2, write a 8051C program to send two different strings serially on serial port of 8051. Assume a switch SW is connected to pin number 0 of port 2. Monitor this switch and make a decision as follows. If switch is 0, means switch is closed, then what, send your first name, and if uh, switch is open, then send your last name. Okay, assume crystal frequency of 11.0592 megahertz and set baud rate to 9600 and 8 bit data format and one stop bit. Okay, so see, include reg51.h, then S bit SW is equal to P2 caret 0 semicolon, means I am representing pin number 0 port 2 by symbol SW. SW is S bit type of variable. So to this SW I am assigning address of pin number 0 of port 2. Okay, so address of pin number 0 of port 2 will get assigned to SW. Okay, which is S bit type of variable, means now onwards in program I can refer pin number 0 of port 2 by using symbol SW. Then void serial TX, so same function, that will transmit a single character that is being passed to this function. So we are declaring this function serial underscore TX, to which I am passing unsigned char type of variable. Okay, then main function void main void. So this is the void main void function. Inside this, see unsigned char x, I'm declaring x as unsigned char type of variable, local variable. So this x is different. This x is declared inside this main, and this x is declared in this serial tx. So these two x variables are different. Okay, so I can use here different symbol instead of x, so that there will not be any confusion. I will use y. Okay, and in the following program I will do the modification. Okay, so here I will use later y here also y. Similarly, and here 1, so there will not be any confusion. Okay, now see the main program in main function. Okay, so here first I'm declaring this y as unsigned char type of variable, and then I'm declaring unsigned char f underscore name. So f underscore name, and after that square brackets, opening and closing square bracket, means I'm declaring f name as unsigned char type of array in which I'm storing string, that is first name. F name means first name, Amitabh. Okay, so this is the string I'm storing in this f name array, and again one more array I'm declaring having name L name, means last name of unsigned char type, in which I'm storing this Bachchan string. Okay, so this is the first name and this is the last name. You can store your names in this arrays. Okay, so these two strings I am transmitting serially depending on what is the status of this switch that is connected to pin number 0 of port 2. If it is 0, I am transmitting first name, that is Amitabh, and if it is 0, I'm sorry, if this switch is 0, then I'm transmitting first name, that is Amitabh, and if this switch is 1, I'm transmitting uh, last name, that is Bachchan. Okay, now SW is equal to 1 semicomma, I'm configuring that pin 0 port 2 as a input pin. Okay, then T mod is equal to 0x20. So I am configuring timer 1 in mode 2, that is 8-bit auto reload mode, because timer 1 is used to generate baud rate or to set baud rate. Okay, then what baud rate I want? 9600. For that I am loading FD into TH1, and then I am configuring a serial port. Okay, in mode 1, that is 8-bit UART mode, by loading 50 into SCON, that is serial control register, serial port control register, and then I am turning on timer 1 by making TR1 bit 1. Okay, now that will generate baud rate of 9600. Now I can begin the transmission. Now while one means continuously, what will happen? Whatever program in this while loop, that will be get executed continuously, infinitely. That is the infinite while loop. So inside this infinite while loop, I'm testing or I'm checking this switch. Okay, if switch is equal to 0, means that switch is closed. Okay, then what we have to do? We have to send the first name. Okay, so for that, program is written below. So under first name, there is a first name Amitabh. We have to transmit serially a character at a time. So for that, there is a loop for y is equal to 0, y is less than 7, y plus plus. Y is less than 7 because uh, this y will range from 0 to 6, because there are 7 characters in Amitabh, and these characters we have to send serially starting from A. Okay, so for that, for loop is repeating 7 times. Okay, and every time what I'm doing, I'm loading next character into sbuf for the transmission. Okay, so sbuf f name in square bracket y is starting with 0. Okay, means first time when this for loop statements gets executed, what will happen? So first name f name in square bracket 0 means it is referring to this first character A. Okay, so that will get loaded into sbuf. Once it will get loaded into sbuf, it will get encapsulated in between start bit and stop bit, and its transmission begins. Okay, and after ending the transmission of all these characters, uh, uh, that is the character that is loaded, all the bits of characters that is loaded into sbuf, that is the ASCII code of A. Okay, once that transmission ends, what will happen? TF flag bit will get set. Okay, so until that TF flag bit becomes 1, your program will be in this while loop checking TF flag bit for 1. Once that TF flag bit gets set, means whatever character you have loaded into SBUF, its transmission is completed. Okay, that is transmission of character, first character, that is A of first name, that is completed, and program will come out of loop and will go to the TI. Next statement, TI is equal to 0, means we are resetting TI flag bit for next cycle to send next character. Okay, in this way, what will happen after this? Y will get incremented by 1, and again Y is less than 7. Again, these loop statements will be executed. SBUF will be equal to fname in square bracket. Now value in Y is 1, means it will now refer to the next character in this fname string, that is M. Okay, so ASCII code of M, okay, we'll get, that is fname in square bracket 1, means it is referring to this second element in this fname array. So that ASCII code, okay, will get loaded into SBUF, and once it get loaded into SBUF, again same thing happens, means it will get encapsulated in between start bit and stop bit, and its transmission begins. Until the transmission of that character ends, your program will be in this loop, while loop, and once that TI flag bit becomes 1, means transmission ends, again control come out of this while loop and go to the next statement below, which resets TI flag bit. In this way, this for loop will repeated. If this for loop will be repeated how many number of times? 7 number of times, and it transmits all these characters serially on TXD pin of serial port of 805. Okay, now this will happen when switch position is equal to 0, means switch is closed. Now suppose if switch position is not 0, means it is open, what will happen? What should happen? The last name should be transmitted serially. Okay, now this condition is not true, so this program will not be executed. Okay, so whatever enclosed in this two braces, this program will not executed. Also, what will happen? If this condition is not true, then else this part of program will be executed. This. Okay, so again this is the loop, for loop, which will be repeated how many number of times? 8 number of times. Okay, because in last name, L name, okay, if switch is 1, means now we have to transmit serially what? That is the last name, that is BACHCHAN. So these characters, okay, our last name we have to transmit serially. For that, program is written here. Okay, if that SW is not 0, means it is 1, what will happen? This part of the program, whatever enclosed in between this opening and closing brace, else this program will execute, and this program will transmit, okay, L name, whatever characters are there in L name. Okay, total number of characters in L name are 8. So these characters will get transmitted serially, as I explained earlier. Okay, so in this way this program works. If this switch position is 0, it will transmit fname, whatever characters are there in fname array, it will transmit serially one at a time starting from A. Okay, and if that switch position is 1, then what it will do? This program will transmit last name, that is in L name array, that is this BACHCHAN. Okay, starting from character B. Okay, so this is the program. Okay, now I will just build this program, check for errors. So there are no errors. Now I will go in debug session. Here I will also view the port 2 bits, because port 2 bit number 0, okay, that is this bit. Okay, so this bit is being connected with switch. We are assuming that switch is connected to this pin 0 of port 2. Okay, and if this bit is 1, what will happen? Last name will be transmitted, and if this bit is 0, what will happen? First name will be transmitted, and first name and last name are stored in this F name array and L name array. Okay, now see the execution. Now I will execute. Okay, so SW is equal to 1, that will configured as input pin. Then tmod is equal to 0x20, that will configure timer 1 of timer 1 in mode 2, that is 8-bit or auto reload mode, that is required to generate or to set a baud rate of serial port of 8051. Then TH1 is loaded with FD, that will set baud rate to 9600 bits per second. Then SCON is loaded with 50, it will configure serial port of 8051 in mode 1, that is 8-bit UART mode. And then I am turning on timer 1, it will set baud rate 9600. Now if switch is equal to 0, now see here switch position is 1, it is not 0, means this part will not be executed, means switch position is now 1, so it should transmit last name. Now see, from here control will come here else, okay, and it will transmit, okay, L name. Now here I will add breakpoint, okay. So sbuff, okay, so first character will be, that is B, okay, so B will get loaded into sbuff, okay, so sbuff, what value, 42, that is the ASCII code of B, letter B, okay, in L name. So first B will get transmitted serially. Now I will run this program and it will stop here at the breakpoint, because TI flag bit is set, means this 42 ASCII code of B is successfully transmitted via TXD pin. Okay, now this loop, this will reset TI flag bit and value in Y now. So sbuff is loaded with 41, okay, BA. Now next character is A, after BA, okay, is its ASCII code of is 41, okay, so that is loaded into sbuff and that will get transmitted serially. Now I'll run the program and it will stop at the breakpoint. So once the program comes out of this while loop, okay, it is stopping here. So it is coming out of loop because TI flag bit is set, means the transmission of that character A, okay, that is ended, okay, so that is character is successfully transmitted via TXD pin. So TI flag bit is set, now we have to reset it, okay. In this way all the characters will get transmitted, okay. So I will run this program. So 8 times I have to run this program. Run. Every time it will stop at the breakpoint. Okay, so now let us see. Yes, again it is coming here. Okay, so now that means this program has transmitted the last name, that is Bachchan, serially, because switch position was 1. Now I will change this switch position, now it is 0. Okay, now let us see what happens. Now switch position is now, switch is uh, now closed, okay, means it is 0, means it should now transmit the first name. Now see, okay, now is if switch position is 0, now the program control is coming here. Now it is executing this part, this for loop, which will transmit first name, okay, that is there in f name array. Okay, in this way, see here what happens for, okay, so 41, okay, which is the ASCII code of A, that is Amitabh. Okay, from Amitabh first letter is A, that is first name, first letter A. Now it will transmit A, and this for loop will be repeated 7 times to transmit that whole first name string, that is Amitabh. Okay, in this way this program executes. Okay, so in this way you can do programming of serial port to transmit data serially on TXT pin. Okay, so in the simulator it is not possible to uh, program for receiving data, because we have to receive data serially on RxD pin, and that is not feasible in this simulator. Okay, for that you have to use hardware. Okay, so in this way the program, this second program um, performs. It transmits first name, okay, if that switch position is 0, and if switch position is 1, it transmit the last name. Okay, so you can study these programs we have studied. Okay, so this is about serial port programming for transmitting data serially. Okay, so uh, okay, this is about practical number 6. I will send you write up. You write these two programs only in the write up. Okay, okay, I will stop here.